What's going on, you guys? Mr. Allen here. We are about to solve for x in these radical, get it? Radical equations here. We got 3 examples. It's going to be dope, right? And we're also going to check for extraneous solutions. Yes, we can have extraneous solutions with radical functions, radical equations rather, just like when we were solving rational equations, you can have extraneous solutions. Anytime there's a domain restriction outside of the all real numbers, there's the potential for extraneous solutions to happen. All right, let's get after it. First one here, I got a cube root. So we got 2 times the cube root of x plus 6 plus 10 equals 0. So first thing I'm going to do here is I'm going to subtract 10 on both sides. And I have 2, then the cube root of x plus 6 equals negative 10. Now I want to get that cube root by itself. So I'm going to divide by 2 on both sides. And now I have the cube root of x plus 6 equals, that's negative 5. All right. Next thing, how do I get rid of my cube root? Well, I got to do the opposite of that, right? I got to cube it. So I'm going to cube both sides. Boom and boom. Now, these guys cancel each other out, leaving me with x plus 6 equals, what is negative 5 cubed? Well, negative 5 times negative 5 is 25 times negative 5 is negative 125. And now I have x equals, after I subtract 6, negative 131. That is it. All right. Now, we don't really need to check for an extraneous solution here because it's an odd degree, right, or a cube root. I can cube root a negative number. I can't square root a negative number. So throwing that guy back in there, working it all out would work out just wonderfully. Check it out. Negative 131 plus 6. That's negative 125. Cube root of that is negative 5. Times 2 is negative 10 plus 10 is 0. Woo! I just mental mathed that, bro. Dang, that was sick. All right, let's continue, right? Let's continue. Okay. We got 1/2 times the 4th root of 2x plus 1 plus 12 equals 8. So once again, I'm going to start at the same. I'm going to subtract 12. Okay. And now I have 1/2, then the 4th root of 2x plus 1 equals negative 4. All right. Now, we'll go one step further. I'm going to multiply by 2 on both sides just to show you guys what's up, right? Multiplying by 2 would undo that 1/2 right there. And I've got the 4th root of 2x plus 1 equals negative 8. Now, question for you guys. I have an even degree root, right? Anything I have in here is going to give me a positive out, okay? If I had a negative inside here, then we just can't do that. I got a positive number in here. I'm taking the 4th root of it. It gives me a positive answer. Is there any way for this to work out? Can I get anything here that would give me negative 8? No, that is not going to happen. No solution here. I love doing the circle with the boom, right? No solution. You can also write out no solution. Okay, we could have gone through this process by raising to the 4th power on each side, which would give me whatever 64 times 64 is. This would be big, right? And then subtract 1, divide by 2. I get an answer, but it would be extraneous, okay? So this one's a no solution. If you have an even degree root, right, 4th root, square root, 6th root, and it equals a negative number, it cannot happen. You can stop right there and save yourself time. That's a big deal when you're taking a test, right? No solution, boom diggity, that's dope. All right, let's continue. Light blue now, baby. Light blue. All righty. I've got square roots on each side. Right? But it's multiplication. I got coefficients in front. So how can I undo those radicals, right? I can't isolate a radical. Here I isolated the radical, and then I cubed both sides. Here I isolated the radical, and I would have raised both sides to the 4th power, but we already knew it was no solution. Here I cannot isolate my radical, right? That's my first step. Isolate the radical, raise it to the exponent. That would get rid of that radical. So here, I'm just going to square both sides. And when I square both sides, I got to square that entire side, okay? Meaning this exponent of 2 is going to hit that 3 and the radical. It's going to hit that 5 and that radical. So now I have 3 squared is 9, and then it's just 2x plus 5, right? The square root and the squared undo each other. Equals, and now I got 25. 5 squared is 25. And then I have x plus 2 over 5. Woo! Almost out of room. Hopefully we can see it. Can we see it? I can watch it on my watch. It's pretty cool, right? Yeah. All right. Cool. We're good. We're good. We're Gucci. Okay. Now, I'm going to go ahead and distribute, right? I'm going to distribute. So this is 2/5. That's freaking me out, right, at first. But then I'm like, oh, wait. That 25 is going to play nicely with the denominator of 5. So 9 times 2 is 18, x. And then 9 times 5, that's going to give me 45 equals. And then I got 25x. And then that 25 times that 2/5. What's 25 divided by 5? That is 5. Times 2 gives me 10. Oh, how wonderful, right? How wonderful. Now, I like to keep things positive. I'm a positive dude. So I'm going to subtract 18x on both sides, right? That's going to give me what here? We're going to have 7x. And then if I subtract 10 on both sides, I'm going to be left with 35 over here. I know we love to have the x on the left-hand side, but, you know, in the essence of keeping things positive, right? Positive spirit. And also, who wants to deal with negative numbers? Now I can just divide by 7. I'm going to get x equals positive 5. Now let's double check extraneous solutions, right? Is this going to cause a negative inside of my radical? Here I'm going to have 10 plus 5, that's 15. We're cool there. I'm going to have this one to be positive as well. I'm not worried about this solution, right? It's not one of my domain restrictions, so we are good to go there. All 3 of these bad boys done. 3 different roots, cube root, fourth root, square root. Dang, son. That is dope. Super dope. Awesome. You guys are awesome. I'll see you dogs later.